Yeah, we're going. We're good. Off we
Okay.
go. And action.
No, we're not. Are we?
No, yeah, we are. Yeah.
We are good. We are good. Okay. Hello, everybody. Today, I'm really excited today because I want to introduce to you the Plimpton 322. It is a Babylonian clay tablet which is stored in Columbia University in the United States of America. Now, this tablet is one of the origins of equations. Many people think that they were actually invented by maths teachers just to punish or torture children. That's not the case. In fact, they've got a long and well-distinguished history. I could go on about the Plimpton tablet for quite a while, but that really wouldn't help us today. So what we're going to do today is I'm going to show you how to do two-stage equations over here on the board. Okay, so two-stage equations. Building on from the work of the one-stage equation, we're going to tackle this in, you've guessed it, two stages. Our first stage, we're going to look at taking or adding a number, that's in the green, and the second stage we're going to be looking at multiplying and dividing. Eventually, we'll get a solution to the equation. We're going to use our bubble method. So if I've got the equation here, 3x plus 2 is equal to 17. The first thing I've got to do is I've got to look to see if I've got a plus or a minus, which I can get rid of. Yes, I've got a plus there. So remembering, when we were doing equations, we were doing the opposite or inverse. So the opposite to plus 2 goes in my green bubble, which is minus 2. And remembering, what we do to one side, we must do to the other to make sure the equation balances. So, I put my minus 2 in my bubbles. Now I've actually got rid of the plus 2 on this side. So what I need to do now is I've got to take away 2 from 17, which will give me 15. So that's the first stage. Stage 1 is done. Now we can go to stage 2, which we've done before in previous work. So, looking here, I've got a red 3, that means 3 times x. The opposite of times is divide, so in my bubbles I've got to divide by 3. I'm dividing by 3 and dividing by 3 here. So how many 3's make 15? The answer is 5 3's make 15. That gives me an answer of 5. So that's the first example done. I want to show you 2 more examples over here now. Next example, here we have 7x take away 5. If you notice now we've got a minus 5 here, so again in our green bubble we've got to do the opposite or inverse of minus 5, which is adding 5. So we add 5 to both sides. That gets rid of the green minus 5 from that side. Then on over here we're going to have 65 and we've got to add the 5 to it. Remember, we've got to balance, we've got to do the same thing on both sides to give us 70. And then finally, how many 7's make 70? We've got to use our divide here, divide by 7, divide by 7's, and the answer is 10 7's make 70, so the answer to this equation will be x equals 10. The final thing that I want to show you, I'll have to get down on my knees for you as I normally do. So, we've got x, something different here. We've actually got a divide time, but we'll come to that a little later. Main thing, stage 1, our green stage here, plus 7, minus 7. Do the inverse. 12 take away 7 gives us 5. So x divided by 4 is 5. Remember that little line there means we're dividing. So to get rid of a divide, we've got to use the inverse, which is to multiply. So this time in our red box, a multiply by 5 goes. So we're going to have 4 multiplied by 5.
By 4.
By 4. And the cameraman has interjected here and showed me the deliberate mistake. Where would we be without the cameraman? Good. So, x multiplied by 4 now gives us 5 times 4, which is 20. Put me right off my stride there, but it doesn't matter. So anyway, to recap, let's go through it again. First of all, we've got the plus minus stage. That gives us a minus 7 here, inverse of the plus 7. Then we've got to divide by 4 here, so that means a multiplied by 4 goes into our bubbles. So x times 4, 5 times 4. 5 times 4, we multiply these two numbers together, and that gives us a final answer of 20. So there we have it. We have the Plimpton Town.